for finding time for joining us in this 5 days virtual training program. We appreciate your efforts and time to be with us. So let me start with my own introduction. I am Dr. Preeti Kumari, organizing secretary of this particular training program and also one of the co-PI of Nahib Caste, Anand Agriculture University, Gujarat. I take this privilege to welcome all the dignitaries in this inaugural session. A very special thanks to our Honorable Vice Chancellor, Dr. K.V. Kathiria, Directorate of Research and Dean PG Studies, Dr. Mpkv, Assistant Directorate of Research, Dr. Shah, National Coordinator, Nahib Caste, ICR New Delhi, Dr. Prabhat Kumar, our Chief Guest, Dr. S.M. Nalawade, Principal Investigator, Dr. Aris Pundir, Core Co-PI IT Group, Dr. Dhaval Kathiria, Principal and Dean College of Horticulture, Dr. N.I. Shah, Joint Organizing Secretary, Dr. YLR, and my dear participants. This indeed gives me a great pleasure to be with you in this 5 days virtual training program, which is on smart farming, application of AI, robotics, IoT, and cloud computing, which is organized by Center for Agricultural Market Intelligence, Nahib Caste, in collaboration with College of Horticulture and College of Agriculture Information Technology, Anand Agriculture University, Gujarat. So this training program is built with intent of active and interactive learning about how the digitalization concept turns our farming system into smart farming culture. And we all know that nowadays phone works much smarter than we human does, in particularly in case of labor intensive or human intensive tasks. So yet our farmer are totally dependent on conventional method of farming system, which yields them into not so profitable business, even irrespective of its importance nationally and globally. Hence, we come up with this smart farming solution, which involves IoT devices, artificial intelligence, robotics, big data analytics, cloud computing, and other digital-based technology. So at the very beginning, I would like to invite Dr. Aris Pundir, Principal and Dean, International Agribusiness Management Institute, Anand Agriculture University, and also Principal Investigator of this Nahib Caste, Anand Agriculture University, for his welcome address and introductory remark. So over to you, sir.
Okay. Thank you, Dr. Preeti, and for brief about this introductory parts, and also welcoming all our dignitaries and the participants also. A very good morning to one and all. First of all, I also welcome my Honorable Vice Chancellor. So he has asked us to join this program a little later. He has sent his the best wishes for this program also. We have requested. He is busy with some other programs. I also welcome our DDG, Dr. Ash Agrawal also. Probably he may not be able to join, but they have sent their best wishes. They know about these all programs very well. And of course, with us, our Director of Research and Dean PG Studies, Dr. Mpkv sir, and Dr. Prabhat, National Coordinator. Probably he'll be joining shortly these programs. We had a discussion with him on this very, very important area, which we are going to discuss in the next 5 days. And yes, of course, our chief guest and keynote speaker, Dr. S.M. Nalawade sir. Welcome you, Dr. Saab. And we are here very much to listen you today, and we are very curious to listen you. And you know about these all programs. All this is, you know, the PG students oriented programs under NAHEP. You know very well about these programs. So we are very curious to listen you today to understand this very, very important area, which is timely and vital. So we are just with this training programs trying to understand these things, and we'll also be sharing something what we are doing here under these IT groups. So welcome you once again, sir. I also welcome my colleagues, Dr. D.R. Kathiria Saab, our IT director and CCPI of this IT groups. We have 7 groups under this Center for Agriculture Market Intelligence under Nahib Caste, and one of the group is IT group. Dr. Kathiria is our CCPI, and this program is being conducted under this group. Of course, our principal and dean of horticulture, Dr. N.L. Shah Saab, welcome you, sir. Our colleagues.
Thank you.
Yes, sir. Welcome you, sir. And of course, our joint secretary, very dynamic, very intelligent, and Dr. Preeti Kumari, other colleagues who are participating here from AAU and who are team members, and of course, all the participants. I will also welcome all of you. Actually, we have to say a few things, just general as a PI of this project. I don't have much to say, but 2-3 important points I will have to share. And mainly for those participants who will be joining first time any activity of this, our Center for Agriculture Market Intelligence under NIHEP CAST. First thing is this area, and though we have done some work in this area, but this is the most important area. Application of artificial intelligence, robotics, Internet of Things, and cloud computing. This is very, very important and vital area, but only we can say only few institutions have done some work, and this whole area is in the nascent stage, but the future is centric to this area. So with the application, its significance and the scope of the application under this 5 days training programs, with the help of these experts member, including our chief guest today, Dr. S.M. Nalawade, we and all the participants will try to understand its significance technically. And the purpose, as Nalawade you may like to say something maybe on this line, that because this program or this NIHEP CAST is a CAST component is centric to PG students, doctoral students, and faculty members. How these faculty members and students can take up leads in the new areas, frontier areas of technology, like this one of application of AI, robotics, IoT, and cloud computing. This is one of the core area under CAST components. So we would like these, our students, mainly PG students and faculty members, to understand the significance, and this I'm sure will help them in designing the new programs, which is the ultimate objective of NIHEP CAST, for improving the quality of education, mainly focusing in under CAST on research components. This is one thing. And because we'll be learning and many things from the teams member, learned participants over the next 5 days, this is one thing. Second, sir, as far as this our Center for Agriculture Market Intelligence is concerned, on 2019, now it is completing about 2.5 years, this Center on Agriculture Market Intelligence was established. And now this has been extended under NIHEP CAST for 2 more years, though it will depend on how much time is given to each centers. So there are a number of activities, and 2 major activities of the Center of this Agriculture Market Intelligence are research components and capacity building. Under research components, we are here conducting research. Number of projects are there. Mainly 18 research projects are there. Some are likely to be completed very shortly. They are on the verge of completion with the help of some experts, members, or outside the universities, or you can see the consultant, well-known consultant, which include 4 major areas in market intelligence. One is price forecast, demand and supply. And within that also, we are having the privilege, we can say we are also doing one very, very important project with the help of ISRO Ahmedabad. And this today's topic area is very, very important related to this one, because we are also trying to understand with the help of satellite data and use of artificial intelligence and machine learning, and to develop some hybrid model which can help us in making the projections, price projections, more precise compared to the existing models we have. Normally univariate models we use in price forecasting. So we are trying to develop this model, and this is very well in line of this one. And this apart, we are also conducting some studies in the global intelligence, understanding the international trade in the broad area of agriculture and allied activities. It's not only limited to crops, but allied sectors like dairy, animal husbandry, fisheries, poultry. This is also the area of our domain. And third thing is the marketing. Marketing is the key, it may be the domestic markets, including the institutions like ENAM and others, to understand with the help of research, review of literatures. And the 4th one objective of this center is conducting research in the broad area of commodity markets and farmer producers organizations, which are considered as harbingers in today's time to enhance the bargaining power of farmers. Unless the farmers are united in the form of cooperatives or FPOs, it is very, very difficult that the farmers will get the benefits of any technology like this one. We shall be discussing this program also. Or maybe they cannot get the benefits of open economy model or the marketings in today's open economy. So these are 4 basic objectives wherein we are conducting the research. Mainly this is for those who are joining first time to this center's program. And the second equally important program is the capacity building programs. More than around 70 programs, if I'm specific, it is 67 programs for the last 2.5 years have been conducted under this sector, taking from 1 day to more than 10 days programs. So, and we have received the very good feedbacks, and all programs are centric to these PG students and faculty members, though the policymakers, the farmers are also there, and some programs are centric to the farmers. So this component or this today's 5 days training program is an integral part, or it is under the second component of capacity building of this IT group of our center. So these are two things. We have received the good feedbacks from different agencies, including our ICRs on the progress of these institutions. And this is all brief to say something. Only last point from my side is that you are looking to listen some esteemed members, learned people in this area, which is not only vital, but we are looking to understand this. And so that our students who are associated with this project, or maybe who are not associated but part of our university, or maybe a university of other universities, they can understand the significance. And this kind of training programs will go a long way. This is what we believe in designing and forming the research project of the students, PG students and faculty members. With these things, we hope very much that definitely this will go a long way in understanding, in increasing our understanding in this very, very important area. That's all. Once again, I welcome all the esteemed speakers, guests, our chief guest, and all the dignitaries in this 5-day training programs. Over to you, Preeti. Thank you.
Thank you, sir. Thank you very much for your humble words and explaining the objective and as well as importance of this particular project, Mpkv. Now, I would like to invite Dr. Ndvi Shah, Principal and Dean, College of Horticulture, Anand Agriculture University, for his remark in this inaugural session. So, over to you, Shah, sir.
Thank you, Preeti. On the occasion of the inaugural program for the 5-day virtual training program on the smart farming, President Dr. Mpkv, Director of Research, Anand Agriculture University, Sanjay Shah, ADR, Anand Agriculture University, our Chief Guest, Sachin Nalawade, Head Professor and Department of Farm Machinery, Power Machinery, Rahuri, and Dr. R.S. Pundir, Principal and Dean, IABMI. The topic, whatever the selected, is the need of the future, and I may say that the need of the present scenario. With respect to the horticulture, when I am dealing with the horticulture, I may say that at present, in the numbers of the field, the smart farming applications of AI and sensor is already going on or nearly to the start, and farmers are willing to adopt it. Here, I am giving some example. In the horticulture at present, protected cultivation is day by day area under the protected cultivators is increasing, in which 5 different factors is the most important. That is temperature, humidity, oxygen, carbon dioxide, and light. These all the 5 factors at present under the complete protected cultivations by different sensor or by different robot, we can able to manage it, we can able to control it, and on the basis of that controlling at present protected cultivations is day by day AI is increasing and farmers have started to adopt it. Nowadays in the horticulture hydroponics, vertical farming is started to grow on, and many farmers are willing to do it. In that vertical farming, in the hydroponics also, among the different 5 factors that is I have explained, another factor, the control of the EC, control of the pH, and identify the specific micronutrient from the plant or specified area is now started to adopt in the horticulture. And in the hydroponics, we can immediately say that this plant is at presently deficient to the particular this nutrient, and that can be possible by utilizing the specially detailed sensor, and utilizing that sensor, a particular plant or particular area, whatever the maintenance process or whatever the applications we needed, we have started to use it. But at present, whatever this technology is there, slightly costly. and due to that cost, small farmers, marginal farmers are not that much able to utilize it. But when whatever the new research was going on, whatever the cost related aspect is start to taking the research on it, I think in the future of the horticulture or the future of the agriculture, we may say that smart cultivation, smart farming is a need of the future. And in the horticulture, at many fera, in many area, now farmers have started. Here I want to give one example. I have seen numbers of farmers, they are adopting the drip, and on the basis of the evaporation ratio, they may calculate on the basis of cloud-based data, and on base that data evaporation rate they are calculating on that basis. Whatever our scientists say, that basis they are utilizing the drip, and on the basis of evaporation transpiration rate data collected from the outer side, they are utilizing, and the drip sequences or drip irrigations method they are adopting, and they are saving water, and accordingly they are doing. In many phases now intelligence-based forecasting of the weather, and by the forecasting of the weather also farmers are able to identify whatever the new insect or pest or disease may be come. On that basis, farmers are estimate and precautions measures are utilizing. So in the future, smart cultivations or smart farming is the need of the future, and whatever that is, we are going to organize 5-day online training program for that. Really, it may be needful and it may be useful to the farmers, and whatever the PG students joined with this training program also got some idea, and they may use it in future research work. Thank you, Preeti.
Thank you, sir. Thank you for your valuable information, and it will definitely help our participant to get an overview of the concept of smartness in our farming system. Dear participants, as our PI said, our Honorable Vice Chancellor, Dr. K.V. Kathiria, and DDG Education, Dr. Asi Agarwal, would not be able to join us in this inaugural session due to his hectic schedule. And we are expecting our Directorate of Research as well as National Coordinator Nahib Cast, Dr. Prabhat Kumar, ICR New Delhi, will be joining us in some moment. So without any further delay, we will take our keynote speech first. And for that, let me introduce our keynote speaker, Dr. S.M. Nalawade. Sir is professor and head in the Department of Farm Machinery and Power Engineering, Mpkv, Rauri, Maharashtra, and has cumulative experience of 22 years in the area of agriculture mechanization and power engineering. He is also working as co-investigator of Center for Advanced Agriculture Science and Technology on climate smart agriculture and water management, which is funded by World Bank. And in that, he is responsible for precision machinery, drones, robotics, and IoTs. Sir and his team has developed one robot named as Fule Robo, which is portable and remotely operated rover, and they are awarded as winner in Agri India Hackathon for this device. And his team are currently developing AI-based harvesting robot, sensor-based site-specific applicators, automatic vegetable transplanter, and research on drones are also in progress. So with this, I would like to invite Dr. S.M. Nalawade to deliver his keynote address with our participants. So over to you, sir.
Thank you, Dr. Preeti, and Honorable Dr. Pundir, Dr. Shah. Thanks for be with you on board here for inaugural session of this session on smart agriculture. Where am I audible clearly? Yeah.
Yes, sir. Yes, sir.
Yeah. Okay. So the Honorable Vice Chancellor, he may be joining later on. Professor Kataria, and other members of your team, and all the participants. I hope all the participants have joined through YouTube link.
Yes,
They are
sir.
not on Zoom. Okay,
Yes, sir.
so it will be a little bit difficult in interacting with them. Okay, but still we will be interacting through some chat box, and you can have those questions afterwards. But here I would like to welcome all the participants from India and abroad, and with very short introduction of our project and the basically what we are going to do in this particular training program.
Sir,
Yeah.
to give you a brief, total approximately 1100 participants are registered in this program, and out of them 70% are PG students and faculty members, and rest of them are UG and farmers and stakeholders, and they have joined us from every part of this country, and also some of the participants are from outside of this country. So it is brief about the participants. So based on that, you just explain your keynote speech.
So I would like to share my screen. Should I start the screen?
Yes, sir.
Okay. So are you able to see my screen?
Yes, sir, it is visible.
Yeah. So I'll start with my presentation, and I will minimize all over. Please let me know if it is visible.
Sir, it is visible, but we are still
in presentation mode.
Yes, sir.
Available?
Yes.
Okay.
Yes.
Yeah. So today you have started very good program, and I hope Dr. Pundir is working very good in market intelligence, and it's you are particularly discussed in based on market intelligence, Center for Agriculture Market Intelligence, and as we are knowing your name in national this higher education program through this CAST, and this particularly challenge area where we have to work hard for Indian agriculture, and here you have chosen this new topic for training these students, mostly our students who are coming from agriculture background or basically rural background mostly. Maybe a few people are from urban background, but most of them are coming from a rural background. So all these words, AI, robotics, IoTs, are a little bit like foreign language, or certain alien things for all of us. I also have started looking into these words in last 3-4 years, when we have started working on AI, robotics, and IoTs with the help of this NHEP project only. So this is starting line. I am the master of my failure. If I never fail, how will I learn? This is the quote by Dr. C.V. Raman, Nobel laureate from India, and with starting this program, greetings of the National Science Day. So today it is National Science Day, and all the participants may know that Dr. C.V. Raman and his Raman effect, a scattering of light. On this occasion, I greet all the participants, happy National Science Day and happy learning, basically. Okay, if these words itself say that these are the words from C.V. Raman. So unless and until I fail, I will never learn new things. So for learning through failures, we need to work on it. Okay. So this is when I am starting with the artificial intelligence. Everybody knows intelligence. The intelligence is with the living beings. All living beings are intelligent, not only humans, but all other things, where we learn different things, we understand with experience, and then use those understandings or learnings for solving problems. That is intelligence. And here, artificial intelligence, what we are talking about, that artificial intelligence is ability of the digital computer or computer controlled robot to perform commonly associated intelligent beings. So those tasks are performed by the robots or machines which are intelligent ones. So that machine has to learn, and that machine has to learn and then to understand the problem, to use cognitive features and to get the output and solve our problems. As Dr. Shah told us about few things which are already in this era are being used in agriculture as a whole world and in India also. Here I have this figure, which is sorry for disturbance. So you may have learned, or you will be listening all these words: machine learning, speech recognition, image analysis, language processing, expert systems, planning, optimization, and robotics. In these 5 days training, I hope your training has been organized such a way that you will learn all these things. So AI, robotics, and IoTs, these are completely related to each other. We can't separate out most of the things from each other. So initially, when we want to learn something, we learn through experience. So machine learning and deep learning are two methods of teaching to the machine. So machine learning, usually it is supervised or unsupervised. As like now you are learning where you are sitting in your home, your hostel, or some place which is not visible to the trainer, right? So when we are sitting over there, that is unsupervised. Nobody is supervising you. You are learning on your own basis. Whatever I am telling you, you are listening it. Maybe you are getting something, and it is unsupervised learning. Supervised learning, that is formal training you got in your school, college, and what we are doing at formal education. That is supervised learning. So similar machines can be supervised and get that learning from intelligence. Okay. Text to speech and speech to text, already you are using it. So you are talking with your Alexa. Alexa understand what you are saying. Then you are putting your words in your mobile, and computer is typing speech recognition. So both these text to speech and speech to text, it is speech recognition. Then image recognition. Most of you might have been using selfies. So when your phone is locating your face, it masks it as with the one frame. And sometimes few mobiles are having features like it will tell you what is your age, and that is nothing but a image recognition and machine vision. Language processing, you need to translate one language to another language. Google Translator you might have used. This is nothing but a language processing, and here we are classifying the words, translating that word into another language, or you are searching through Google engine. When you put some keywords, automatically data is extracted, and it is giving a number of results to you. That is nothing but that's language processing. You can translate in any language and now that can be give you pronunciation also, that is speech. So expert systems are systems which are working on their own and giving you results. Those systems are smart networks, smart phones, and your smart TVs, even your AC, that is air conditioner. It senses the people and give the temperature. If number of people increases, automatically the wind is increased, wind velocity is increased, temperature is reduced, depending on the settings given. And then planning and optimization is a very important thing. As you see, if you know something, then you can calculate, measure it. Then if you measure it, then you can plan it, and you can optimize your resources. And this is the use of your artificial intelligence. And last, that is robotics, what you are going to do or going to learn in this particular training program. So AI is basically in agriculture sense, where we can use this artificial intelligence in agriculture. So crop and soil monitoring, where you can know the health of your crop through some Ndvi values. There are some vegetative indices. Then you can monitor the soil with some sensors and spectroscopy, where you are using spectral cameras, thermal cameras, and then you have a few 3D LiDAR systems which will give you point cloud data, and then you know that amount of nitrogen present in the soil or other ingredients which are present. You can judge the color of the soil, you can classify these soils, and land use planning can be done. Pest and disease prediction, and first you have to identify the pest, then you can use that, which is the disease or pest over there. So identifying, predicting the occurrence of these disease. There are few mobile apps which are already available, but long way to go in this area, and we need experts to be developed in pest and disease identification and prediction. Intelligence spraying, that where we have already worked. Intelligence spraying is nothing but where you want to spray your liquid. Initially, what we are trying to do is to protect the environment and keeping that crop at optimum level, so that it will produce maximum. The quality as well as quantity of your crop is very important. And doing this, you need an intelligence sprayer, where you want to spray, when you want to spray, and put the quantity which is required only at the place where it is required. Predictive analysis, as Dr. Pundi said, that we need prediction in market intelligence. When you know a market intelligence, when that what will be the rate and where will be the cost, and what should be the cost benefit ratios, that predictions are there. Similar predictions are needed: when to sow, how to sow, how much to sow, which crop has to be planted, with environmental parameters, then local parameters which are deciding it. Then last one, agricultural robotics, which is used in various areas, weed management, then harvesting, and big machines which are controlled automatically through data provided. That is, those are auto steer or automatic machines. These are the areas where we are working, and you can see a lot of people are working in this area. You will go and search on the net, you will find tons of references available over there. You should go for particular papers. Here on the left side, you can see the data which is collected by the robot when it is moving, and while working it can collect the different data, canopy temperature of the crop, and then water stress, the Ndvi values, the ambient temperature, atmospheric pressure, relative humidity, then you know that where this robot is moving, and all these data, even the survey, that is where the location, GPS location of that particular position sensors there are. GPS is global positioning system, and which gives you exact location of your machine. So this is the data which is available. So this is what we see here is the mobile screen which shows the location of that particular robot. Okay. Then on right side, you see there is a program by it is in Myanmar actually, and done by with the help of this AIT scientists in from Bangkok. They have written this particular paper, and the drones which are flying robots. So this is also a robotic form. There may be flying robots, there may be ground robots, and there may be aquatic robots. So every robot will be discussing that what is the robot. Okay, but that is used on the left side. You can see this data which is collected and separated into Ndvi values. Ndvi is normalized differential vegetative index, which is useful for taking certain decisions on site-specific application of fertilizer, watering, and pesticides. So that is biotic and abiotic stresses can be related. There are various indices which can be used. Next thing is IoT. It is a base for all these AI or your robots. So you need to collect data to understand something. You need to measure first. Okay, first you have to collect data acquisition, and data acquisition is done by some sensors, and those sensors like temperature sensor, humidity sensor, then you can provide that data to collection devices. There may be smart sensors which will directly send your data to cloud, or that may be requested from your mobile user, which is a farmer. Now, when we refer to IoT, IoT is the Internet of Things, refer to implementable machine-to-machine communication. So machines are communicating to each other, not without any intervention of human. That is, so there is a big definition of or complicated definition you can learn over here, the dynamic global network infrastructure with self-configuration capabilities based on standard and interoperable communication protocols, where physical or virtual things. Maybe a virtual thing also. Software can give that data. There may not be something, it get the data from cloud. So cloud, you will be learning on cloud computing also. So cloud services which are provided like Amazon Web Service. Sometimes earlier when we have searched for automatic weather station, so we generally call it as AWS. But when we search it, the data internet provided that Amazon Web Services. Okay, so we get confused. What is that AWS? So Amazon Web Service is a cloud computing service provided by Amazon, and it is mostly used cloud computing service all over the world. There are others like Microsoft Azure, which is also providing same thing. So cloud computing, you need not to have all computers and data at your computer, but you can put those data on cloud and use the services provided by the service providers. Computing capabilities are there. There are various sensors which are placed, collect the data and communicate to directly to the user, or it goes to cloud and then given to the user, or otherwise they can be communicated to each other. Now that last part, what we'll be learning is a robot. So robotics, where we are working. There may be different kinds of robots who are working in agriculture. This picture shows you different uses of these robots. There may be intelligent machines which are continuously working in the field, tilling and planting on barren land. Then fertilizer application. Then you need to know the condition of crop and your environment. That is called as a robotic scouting, or it is monitoring disease and pest also. Then after complete operation, you need to spray that. Those automatic spraying robots are there. And then after doing all the jobs, you will get harvesting, the final removal of your product from the field. That picking, harvesting robots are there. The advantage of these robots, they can work day and night together. There is no thing like a putty unless and until you have a power source with you and that robot with you. Those can even automatically refuel themselves. So that autonomy is still in India. We are looking into small things. So generally what people say that robot is only a human being, which is, it is like a human and working like a human. It is very difficult to get such kind of robots in practical case. So there are different kinds of robots which are working in the agriculture. On the left side, you will see there are different, so initially, it has started with autonomous tractors. Somebody might have seen some videos which was viral by Mahindra's. They have some farmer has developed auto steering mechanism. But in European and American countries, they are already working on these areas. GPS location, or GNSS, the Global Navigation Satellite System, which gives accuracy to your position, and then it commands to the tractors. There are different levels of autonomy from 3 to 5. The completely autonomous tractor, it will not be observed or supervised by human beings. That is available. Then small robots, that now there will be some condition that these big machines are not useful in Indian condition, where we have fragmented land, small holdings, and we are working on small areas. So we need a small machine which will be working, maybe it is slower one, but it will be working for more hours. And these smart machines, here you can see small weeding robots, harvesting, spraying robots, which are present, and they can do multiple jobs. So this is the future, where you will get split of agrobots which are working continuously. Then there are vegetable harvesting robots or fruit harvesting robots which are available, and these area where we need to work upon, as Dr. Shah told about the horticulture mechanization, and there are this is the area where we need the machines which will be continuously working, and they will look beyond the visual or intelligence of the human, because we can see 3 colors only, R, G, and B, red, blue, and green. But the machine can see up to 256 color bands. As today is Science Day, that scattering of light is the experiment given by the done by our Nobel laureate C.V. Raman Saab, and that given that there is a scattering of light and it produces various wavelengths. These wavelengths may be ranging from 300 nanometers to up to 2000 nanometers, where we are interested. And these, out of that, only few, that is only 200 nanometers from right from 400 to 650 around, it is visible range. And beyond that, it is invisible. Below that is also invisible to us. So what we have to do? We need different sensors which can see those lights. So there are multiple spectrometry sensors or hyperspectral sensors. Those can be used. Those can be mounted on aerial robots, which we generally know as drones. And these are UAVs, unmanned aerial vehicles, which are carrying those sensors, and they can go fast. So this is the area. I have told you that intelligent implements which are connected with our regular tractor, those implements also come under the robots. So this is the area where it will go forward, because now everybody will not go for the small robots, but somebody where their area is large, they will go for tractors, and then they should know the condition of operation of various machines. So these are also robots connected with tractors. Then the same thing is useful in dairy farming, where you have already you are from the university Anand, and this Anand is famous for your Amul, and this area has come up with large mechanization and automation in the industry. Somebody, if you have visited Amul, they may know that there is complete automation in industrial side. But on the back end, where the farmers are giving or supplying that milk, or doing some business on milk production, so there are also robots which are available for cleaning, then for ration mixing, and then cleaning and milking also for animals. So this is what we are going to learn. But in this context, this is generalized idea what I have talked about with these three words. But what is our role? What we can do? Basically, somebody says that we are agriculture people, and why we should go into the engineering side. I don't know what is in there, but any industry which is related to you, and you are the user or consumer, last consumer of that devices. So you need to know all these technologies, and you need to work upon it. Nowadays, everybody is having a smartphone with them. These smartphones, you don't know much about the technology, but you know the utility and how to use that technology. So some people may be interested in research. Some people may be interested in manufacturing these devices. Some people may be interested in using the devices. So for each and every person, you need to know the technology, then you can use it. So we have developed a small robotics and drones research laboratory at Mpkv. This is the photograph of that lab, which is developed with the help of a World Bank funded project through NAHEP. So we are doing some experiments with the drone. Okay, at the top right, you are having this complete section where we are having different kinds of drone with us. The hyperspectral imaging drone, fixed wing drone, mapping drone with 3D LiDAR, mapping drone with RGB, spraying drones, spraying and spreading drones. That is, spraying is liquid fertilizer spraying or liquid pesticide spraying, but spreading is granular fertilizer spraying or seeding. Then we need to train the people. So we have practical assembly drones also. So the students in our institute, they come and they assemble their drone, they will fly that drone and get the feel of that technology, so that there will not be any hindrance while using that technology. Now we are inaugurating in afternoon hours only with a E-Yantra laboratory. We have already have set up of E-Yantra, that is the initiative from IIT Mumbai, and it is initiative of MHRDA, that Human Resource Development Authority. Okay, we have with us a few small robots for practical assembly, then learning around it. Even we have with us Lego, which are the playing robots. Means you can build your robo, you have a small processor with it, and program, you can program it to follow the line, you can program it to follow the path, then you can program it to avoid the obstacles or do some things. So this is a few developments which we have done already, and we are doing that. On the left side, variable rate fertilizer applicator. I have told you that this is also a part of robotics. Not only the complete machine, but it is the simple intelligent machine. On the top here, these are the sensors which sense the crop. It converts that crop data, that is color, into intelligence, and it decides how much fertilizer has to be applied. That data gives to given to a controller, and that controller gives a decision to a valve which will be opened for a certain period, and it will apply the fertilizer which is required. So this is a project which is undergoing. This we have developed as IoT devices, the auto pull irrigation scheduler based automatic pump controller. This controls the irrigation pump for particular hours while taking the data from the cloud, and using that data, it will decide how much time it should be operated and how much time it will be giving that irrigation, how much to be irrigated for particular crop. It can be done for various crops also. And last one, this bottom one, we have developed some soil moisture sensors. Basically, soil moisture sensors available all over the world, but these sensors are specifically not designed. You have to calibrate each and every time for various soils. You can't pull out the sensor from one soil, which is light soil, and put it into black soil, and that will give instant readings. So that this is not possible with the single sensor. So we are trying to develop a sensor which can be calibrated for all soils, for all levels, and that can give the data to cloud and directly control this pump. On the right side, proximal sensing platform we are working with for collecting the data. This is indigenous development only, and we are working on that. Okay, these are various kinds of drones which are having this. On the left side, it is quadcopter for spraying. You can see the centrifugal nozzles which are attached here. This is a mapping drone with a thermal and LiDAR sensor. LiDAR is light dependence. This is navigation and ranging. So then fixed wing drone, it is VTOL. VTOL is the vertical takeoff and landing drone. This aeroplane can go up and down directly, and then used for large area mapping. Hyperspectral imaging drone, spraying and spreading drone. Then these are training drones. Okay, all this is about, and basically when you want to have any kind of equipment with you, you need a trained manpower to handle. So we have 5 pilots, which are, we proudly say that out of 50 trained pilots, in first 50 trained or licensed pilots in India who are working in agriculture, and we are working on. So we have learned from the flight training organization, which is Redbird Aviation, and then we are using the technology for communicating all the things to the our students, particularly teaching them the operation, how to operate, how to control, and then to farmers to promote this technology. There are a lot of interactions between industry. We call industry people and give that introduction to the scientists, students. Also, there should be industry and student linkages. Not only the machines, we need to develop some things. We have already come up with few softwares which are mobile applications. You can search on Google Play and you will get that software, Full SAM, which is Ola and Uber in the mechanization, agricultural mechanization. It is free software which is available and you can download it. You can note on that particular software and search for the people who are giving your machines on custom hiring basis. As Dr. Shah said that we are not able to procure, or farmer is not able to procure the high-end technology individually. But here the concept is not hiring, not purchasing or procuring the technology yourself, but you should have another entrepreneur or the people like you who are engaged in the learning. We have already you are graduates, or you are learning some portion in agriculture, or it is related to agriculture. So out of all these 1,000, if even 100 of from the participants, they take up as an entrepreneur and give these equipments on custom hiring basis. So you may know that in India, almost 95% of people, they are using common transport services, or the services provided by the government. ST buses, those state transport buses, train, or even your aeroplanes, those are not owned by a consumer or customer, but these are given on rental basis. A similar thing has to be there in case of agriculture machines and these high-end machines, robots. So that should happen, and this will help in giving those services to farmer, and farmers will get the services in affordable price. So this second one, it is the information generation tool. We have developed a software to assess the need of mechanization and network solution for, so this is policymakers data collection tool, and the farmers will get the data about some mechanization available. So what we have discussed about this Pule Robo. Pule is the brand name given for our Mpkv's equipments, what we have. So this Pole Robo, you can see, this is the portable, remotely operated small equipment. The weight of this whole device along with the spray liquid is only 150 kg, less than your bike. So, and out of that, the weight, that operator's weight is 0 here. So we are using that weight to convert it into a spray liquid. So 70 liters of spray is there. So only 80 kg is the weight of the equipment, and 70 kg is the weight of that liquid which is carried. So this is a simple video at the bottom. You can see. So this, you can see how it operates. It can travel in any terrain where okay, so that was in Hindi, and that's just for description of people who don't understand that English language. So, but here we can see that this was developed in view where the tractors, big sprayers In Maharashtra, in Nashik district, there is grape growers who are using big machines. They have procured machines of around 16 to 20 lakhs from Italy, and they are using those machines in India. But last 1-2 years back, they would not be able to use those machines in grape vines because the climate change and the monsoon was extended up to November, and they even could not spray their fields, and they got highest amount of loss. And the solution is you should have a track type vehicle, and here we have thought about the operator safety. In Yavatmal district, in last 5 years, there were around 35 farmers who get killed because of spray liquid coming in their respiratory system, and because they were applying pesticides in cotton field until after few days of continuous operation, about 35, 50, 40 days, they got infection inside the lungs, because every time you spray, you will collect small amount of pesticide inside. Because if you are spraying at a higher temperature, the droplets are reduced into nano-sized particles, which can be directly absorbed into your blood and lungs. They will get attached over there, and toxicity increases. To avoid that, you need to save your operator. Here, the operator is away from that machine. So he is not even in touching that vehicle. He is operating, he can operate up to 1 kilometer, but currently we are not suggesting that he should see that particular robot. And now we are developing it as an autonomous one also. This is another thing what I was talking about. I hope this video is visible to all.
Yes, sir. Yes, sir. It is visible, sir.
Okay. About these videos are related to our work. On the top corner, I have told you that we have developed this variable rate fertilizer applicator, who was this machine was presented at national level Kritagya and as well as Agri Hackathon, and it was a finalist in those areas. And this Pule Robo got a winner prize of 1 lakh rupees. And also it is that this has to be developed in collaboration with some startups. So we have one startup which is in collaboration with us, and they got incubation about 20 lakh rupees funding for their its multiplication. So that happens in collaboration in PPP mode. We'll be going forward. And now this was our work, what we are doing. There are few things which are there. We are developing one slurry applicator, site specific slurry applicator, and this autonomous robot also. But those are pending for our patenting, so I have not disclosed that. But okay, the use of those machines is finally is for horticulture, that is used in agriculture only. And you can see it's Ideatech X is the company which is researching a market. So you people are working in the market intelligence. This is the future of your agricultural robotics. You can see currently it is up to $50 million, and it has to go up to $500 million, even in billions. So that is the prediction. So these are various type of robots: static milking robot, mobile dairy farm robotics. Mobile means there are rationing and then cleaning and then other activities. Then autonomous agriculture, small robots, small size robots for data scouting, then for weeding, then multi-platform small robots which will do various kinds of operations right from scouting, weeding, spraying, and then harvesting. Everything will be done by that robot. That is also the maximum area is here. Autonomous tractors, AutoSteer level 4, that is automatic operation of the tractors. Autonomous tractors, then robot for strawberry harvesting, fruit picking, then intelligent implements in this area. The small, it may be a little invisible, but can you see this color differentiation? I don't know. But there is a small area where agriculture drones and for scouting, then data services, and then multiple function drones are there, and unmanned spraying helicopters also. But those will be having little future. But still, this whole industry, you can see the market trends in this agricultural robotics, that reduction in the device costs. As you know, when that television, black and white television were appeared in 1980s, the prices were so high. That time it was around 10,000 rupees, small TV available, and then it comes color televisions, so CRT is available. Then it has been converted into LCD TVs. Then LCD is converted into LEDs. Now you have smart TVs with you, but cost indeed, you can see how many years from 1980s, it is almost 30 years. 30 years, the cost of your smart TV, you can procure a small smart TV of 32 inches or 40 inches within 10,000 rupees only. So as you go on increasing the level and the research level and availability in market is increased, the cost remains as the same, or it may reduce also. So that happens. You can see that earlier mobile phones, I know when we have started using mobile, it was in 2000 something. Then we get those mobiles at 3,000 rupees, big mobile, and we have to pay 10 rupees for using that a single minute. And now you are using a smartphone that is costing around 5,000 rupees or 10,000 rupees even. There are some costlier mobiles available, but everybody can afford the technology which is available there. So that happens, that will happen here also. And as the technology develops, that will give rise to reduction in the cost. So that is the main drive over here. So we think that traditional thinking is bigger, often better. Bigger is better. But this is because bigger vehicles are faster and thus more productive. But small, slow robot working continuously will do the same job. So there will be less compaction of your land. You will get more operation. You will work day and night. You have less investment on big machines. So if you go for American devices which are available with good autonomous machines, these 600 HP tractors are also available. But these 600 HP tractors can't be used in India. So we are using around 45 HP, 50 HP maximum. We are having 75 HP. And these tractors also making compaction in our field. To avoid it, we need a small machine which will not compact our field, but it will be useful. So here, doing drones about, we have, it is dollars in 2028 or 2030s. It is prediction in the 2038, about $420 million industry it will be. So what is the advantage? I told you again, the robots can work for 24 hours a day, every day, without no breaks. You don't need to pay the wages every time. So they will not ask you to pay that wage. robots are extremely accurate and compared to human, the precision agriculture. You can ask the robot to put your seed at 5 centimeter distance. Every time it will put it on 5 centimeters only. So that is easier to use other machines afterwards. So quality of product is very high. Robots can perform their task more quickly than humans. The faster operations, you can say, the spraying drone can cover 1 acre of spraying within 5 minutes only. So you can see the space with the humans, 4 human operators with HTP pump, they are spraying around 4 acres of the land all day. And you can cover with a single operator, a single drone, and you can cover around 15 acres per day. So the multiple operations or multiple speed is there. This is easier to use. The robots can work in very dangerous condition. So there are different kinds of robots, which are stationary robots in the industries. There are mobile robots which are working in the field. There are few robots which can go beyond the imagination. Where they can work where we don't want to put ourselves into the dangerous condition like space. They're going in the space. There is no oxygen. They can work over there. In chemicals, they can work. But there are a few disadvantages. Robots cannot be easily adapt to unusual conditions like human beings. So the intelligence and artificial intelligence is different. Still today, you may have seen some robots who are getting knowledge. They are gaining on the in chess. Also, they have give checkmate to our international master and world champion Anand. But this is a few cases, and they have certain limitations. They can't act faster as a human. Currently, it is very slow as compared to human in all conditions. So if the atom is in the line is not in correct place, the human worker can notice and correct it and put that immediately, even an unskilled person. So today's robots, we can say those are intelligent as much as some insect or some animal, but they are not intelligent as human. People may be unemployed because of robots, but this is not true completely. We need to change our skill sets to get into the job. So it will be replacement of type of labor or type of human beings which are being there. So it will be unemployment for few persons, but it will be generating employment for new person with new skill sets. Robots are very expensive, as currently I know that these are expensive one. Okay, and what is takeaway over here? What we have talked about all this hour. So next revolution in agriculture will be technology driven. We have seen green revolution, we have seen white revolution, we have seen yellow revolution, but now there will be a technology driven revolution when our Prime Minister is saying that we have to increase or double the farmers' income. How to increase that? We are having less land, we are having less productivity, we are having problem of marketing. Now the chance is that if you know that cost benefit ratios, you're most of the people who are working in the area of economics, so you better know the cost economics. Okay, the cost benefit ratio, if you can't increase the benefits, reduce the cost. So here the technology will reduce your cost of operation, increase the quality, so benefits will also increase. So AI, robots, IoTs are inevitable for agriculture. They bound to come, and you need to know these technologies. Yes, you have to adapt all these technologies. You need to learn, and better that if you learn earlier, you will be on front. These technologies are interrelated to each other, as I have told you that all these are related. IoTs are used in robots, as well as AI is useful for robots. Then AI is used in IoTs, connecting the IoT devices and learning from these devices. Everything is related. Then these will be certainly beneficial for maximizing farmers' income. I am not talking about production, but I am talking about income. So money, penny saved is penny earned. Same is there. So if you reduce your cost, you reduce your time utilized, increase efficiencies, then you will get more income. These technologies will certainly bring glory and dignity to farming culture or farmers' work. So now new students or new generation is avoiding to get into a farming business, and these technologies will help bring them back into the farming business, and this will cause surely reverse migration, what we say it as. And last, again, I'm closing with this C.V. Raman's quote: you can't always choose who come into your life, but you can learn what lesson they teach you. So I hope I am not being chosen by the participants, and I have given some insights about these robotics, AI, and IoTs with little my knowledge. I acknowledge all my service providers, the funding agencies, Mahatma Phule Krishi Vidyapith Rahuri, Center for Advanced Agriculture Science and Technology for Climate Smart Agriculture Water Management, which is funded by World Bank through National Agriculture Higher Education Project, Indian Council of Agricultural Research. I am very much thankful to all these entities and authorities for giving us opportunity to work in this area. So this is learning only. You never stop learning your whole life. So those people who are young, they should get into this business and learn it. You will be having great opportunities in India as well as all over the world. Those participants who are there from other parts of world, they may be having this particular presentation was related to Indian, so Indian agriculture, but it is having same thing for every agricultural graduate. So I am thankful to organizers for this particular acceptance, giving me chance to speak with you, and I hope this 5 days training will bring some insight for AI, robotics, and IoTs, as well as cloud computing to you, and very happy learning to you. Thank you very much. I'll stop here, and if we can take some questions if they are.
Yes, sir. Thank you, sir. As you said, I also believe that after green and white revolution, we are certainly going to have some digital revolution. I am giving it for fun, black revolution. So we are going to certainly have such kind of revolution after some time. So, sir, I will take some questions from audience side. Sir, first question is, can you provide more detail about Ndvi?
Yeah, actually, Ndvi is the one of kind of vegetative index, which is based on the two spectral ranges, near infrared and red edge. But this you need to know that this is one kind of vegetative index, which is taken from multispectral data imaging, and collected data is being used for it is normalized differential vegetative index. And this basically most of the people, they are relating it to the stresses biotic stresses like pest and disease stress that causes yellowing of the leaves. Okay, but that has to be researched. And the water stresses that it can judge upon water stress, you can use or correlate these Ndvi values with your yield. And there are few people available, you can search upon it, and that will be useful. But there are various indices which are apart from Ndvi. You can use those indices also, not only Ndvi.
Yes, sir. Sir, next question is, for implementing AI or technology-based farming, does government provide any facility to farmer, like any subsidy or other support? Because overall, there are mostly small and marginal farmers.
Currently, I will not talk about AI, but last week only, the government of India has issued one notification regarding use of drone in agriculture, and they have provided subsidy for demonstration. All the institutes which are government institute, they will get 100% of subsidy. Farmers producer companies will give 75% of subsidy, and the agriculture graduates for their own custom hiring centers. There are different kind of custom hiring centers which are developed already by, which are run by cooperative societies or individual entrepreneurs. They will get 50% of the subsidy, and who is not agriculture graduate, they will get 40%. So this is the promotional scheme operated by the government. On the basis of these, there are a few smart projects which are already in operation. With the World Bank funded project only. This is what we say, that you have to produce what we can sell. Same kind of projects are being done in Maharashtra state. They call it as a smart. There is a climate smart project like POCRA project on climate resilient agriculture, and they are providing some projects in that area also. And for procurement and collection of NAFED is providing subsidies. So there are a lot of subsidies and promotional schemes available if you want to come into this area.
Sir, will it be helpful for small holding areas in India? And if yes, then at what level?
I couldn't understand what is the exactly they want to small. Okay, in India we have fragmented land, one. Then we have small farm holders. Almost 87% of farm holding is small and marginal farm, and only 10% is the bigger. It is medium level, and only 5% is the less than 5% is the big farms. But when we go for collective working, there is a chance that we are working together. And now these machines, you can see the robot we have developed that is having width of 80 centimeters. So it can be operated in small areas. It can go into the hills. It can ride, you can say that it can ride up to 45-degree slope. And you can travel into muddy land where is slippage there. So such kind of inventions are needed. There are few people who are working on walking type of robots also. There are some people who are working on drones, aerial vehicles. So drones, and that is a small machine. You can say the small drone which is having 2 kg of weight. It can fly on your 10 by 10 meters area, and it can take pictures of your crop. It can suggest you some decisions and give the data. And you can use the sprayer for your 1/2 acre area also. So we are doing that activity. So it is possible for small farmers, no issues.
Yes, sir. Sir, next question is, What are the institutional arrangements to access robotics in farming by small and marginal holding farmers who have small and marginal land holding of Indian scenario, in Indian scenario?
Okay. So I have already discussed about that small and marginal farmers can come up with their cooperatives or farmer producer company, and they will get better benefits because government is promoting farmer producer companies, and they will be given subsidies because it is easier to protect and guide these people when they are coming together. Also, there are custom hiring centers around 15 to 20,000 custom hiring centers already in working in India, and these custom hiring centers are providing machines. And now that SWAM, that is the scheme for mechanization by the government of India, it is promoting small robots also in it. So there is a very good chance that small and marginal farmers will be there, and graduates, agriculture graduates should come up with some innovative proposal. There is difference between innovation and invention. We don't need to invent everything every time. You need to use those things which are already invented for your use. That is innovation. So utility is also innovation. Good innovation.
Yes. Sir, next is, does artificial intelligence device and IoT devices will function in rural areas where there is no high internet penetration?
IoT devices basically, usually they are connected to internet, but nowadays, when we are using, we have some villages which are adapted. You can see that those villages are in Sahyadri ranges, and there is very less connectivity. You can do this connection with the mobile. So GPRS SIMs can be used or connected to the devices. It is not necessary that every time you need complete internet kind of thing. And it is possible that to collect the data of internet, or you may not have to collect that data directly on internet, but when you come in the range, that data is uploaded to the cloud. So these two ways are there to use it. There are some connectivity protocols like Zigbee and LoRa, etc., which can connect your devices up to 10 kilometers range without any internet. So it is possible.
Okay. Okay. How these technology, IoT or AI, will help to reduce the food or crop waste in long run? Long run production could be the future challenge, but food waste and self-life of producers are current challenges. So in this regard, how these IoT devices will help?
Actually, when you are storing something, those perishable items in stores, you may know that the post-harvest losses in India are more than 30%. And if you can transport these harvested material in controlled condition, if you monitor few things, even some small things like ethanol, oxygen, and temperature and humidity, that will allow you to know the condition around that produce. There are a few projects which are already going on. You may be knowing that cold storages are already there, pre-cooling chambers are there, then cool chain for marketing the products is there. But this is not affordable to the farmers, but you can go for some small things. Usually pre-harvesting, you can go for collecting the data of environment, which is freely available. Then you can use small sensors to know the condition inside the storage, which will give you the correlation between the life, and then you can take the corrective actions over there. So this is possible, and this will help in reducing the losses.
Sir, that person has also asked one thing. Please provide some tips to market and convince how to convince the farmers community to purchase different IoT devices.
Okay, so if you want to come into this business of IoT devices, now you can know that earlier nobody was having a telephone in their home. But now, if you go on the farm labor is having a small mobile in his pocket. He doesn't know what is the technology, but he knows how to use it for his betterment. So unless and until you promote these technologies with the utility, it should be user-friendly, environment-friendly, and that finally it should give some income to that user. That may be ease of operation also. So smartphone users can be your customer first, and most of them, they don't know what is IoT. You should first tell them what is IoT, or what is the use, and what is the benefit. So all this is there. You are the better people to explain this. Dr. Punir is there, who is Master of Economics and expert in it. So that is better. How to market something, it is your call. I am the engineer, and I don't much relate to this. But what sales is, what is my requirement, then I will use that device. So until and unless I relate that use and the application of that device, I will not purchase.
Okay, sir, we have taken all the questions from the audience side, and thank you very much, sir, for such an informative session. All these automated machinery example, as well as your valuable insight, gives us a new perspective that one can adopt while discussing these issues. So once again, thank you very much, sir. So the question from the audience side, and thank you very much, sir, for such an informative session. Now, dear participants, we are at the end of this inaugural session, and I would like to close this inaugural session by a vote of thanks. And on behalf of the entire team, I would like to extend my first and foremost thanks to our Honorable Vice Chancellor, Dr. K.V. Kathiria, whose leadership driven this project from the time of his joining. And yes, sir. Yes, sir. Sir, please.
Priti, Dr. Nalawade Saab is still there. I was interested to ask one basic general thing.
Sure, sir. Please, sir.
Sir, please.
Sir, I think there is some internet connectivity, so we are receiving these things very late. So if you want to ask some question from Nalawade, sir, please, you can ask and you can discuss.
Yes, sir, please. I
yes,
think, yeah.
Dr. Nalawade, one general question. Can you hear me properly or not? There are some.
Yeah, okay. Yeah, I can.
Sir, very general question, but not directly related to this advanced model and other kind of devices. These are important, definitely. And we can definitely, as far as this whole marketing system or management system is concerned, we have to upstream factors, and downstream towards input side, relationship between them, as well as output side, marketing, processing kind of things. These are the things we study partially or exhaustive way, this whole value chain system in agriculture, as far as marketing is concerned. So, Professor Nalawade, one basic and very important for us question is to you. And this is just, I'm asking you, it may not be directly related, but there are some points when we do some analysis for marketing, for trade, or maybe which are more behavioral in nature, then there are some things, some parameters which cannot be quantified. Say, for example, there are many people in the market and who have very good knowledge. And after developing the models, maybe the statistical models, some mathematical, statistical, or econometric models, the combinations. But unless we understand the market pulse by having discussion with these people, we cannot come to some a precise price forecast kind of things. Yes. So is there some possibility that in this kind of studies, maybe the artificial intelligence or maybe the robotics or whatever we are, IoT mainly, IoT, though this is more related to technologies or devices, to address this issue, behavioral issues where data is limited. You can ask me something, I can tell you something, but this is not in a systematic way, in time series way, which helps us in developing some method or ultimately which help us in understanding the overall evaluation kind of things, or you can say data analytics. For data analytics, we need data, but we have based on behavior something which is qualitative in nature. Can we address these qualitative things which have limited quantitative figures? Can we use them here also? Something just a flounty idea, nothing else. Yeah.
Sir, actually, data science is a big field, and now it is coming up, and you can know that Google is the best data scientist, and Google is gathering every data from us only, the users. So we need to know the behavior of stakeholders and then come up with the solution. The qualitative data usually in statistics, you may be mostly the social scientists are using that behavioral data with the surveys and those things. You already might have used it, and you can see that what Google is doing. Google is giving you certain service, and when that means traffic. Suppose you are given a route mapping, and then you are connected with their server. Then that Google is collecting the data from where you are traveling, at what speed you are traveling, at what distance you are stopping, so they can give you the traffic related information also, and that is being done on the basis of the data collected. So initially AI, as we say that from where you are traveling, at what speed you are traveling, at what distance you are stopping, so they can give you the traffic related information also, and that is being done on the basis of the data collected. So initially AI, actually I think there is a time lag, so I have stopped.
Yeah, sir. Actually, we have misconception. Maybe internet issue. This is basically we are simultaneously using YouTube also, and we are in Zoom,
actually,
so that's why it is equal.
So please don't go through YouTube links, because YouTube is having time lag about 2 to 3 seconds, and this time lag causes little bit hindrance. So when we are talking or discussing, that should be on Zoom. So this thing is there in AI, because every time similar things happen. What we are calculating, getting the data, and then communicating. If there is a time lag during this 1 or 2 seconds, that in practical life, these 1 or 2 seconds is very big time as for reaction time. Sometimes, if it is to be used in your data which is given for a driver, okay, and that driver is assisted by your software, and this particularly you are given he is traveling at 100 kilometers per hour. So 100 kilometers per hour gives that speed almost more than 15 meters per second. Okay. And when you are giving this data that you have to stop under 10 meters, so that should be within 1 second, he has to do that activity. Similar thing. Okay, this is one part, but I will answer to Dr. Pundi's question that when we are using qualitative data, we need to get the data from experts. A lot of experts has to contribute to it. The most important part in machine learning is the tagging the images you have produced. Similarly, data which has to be confirmed by the experts, and that is the issue and that is the problem in development of AI. Currently, that's why they are shifted to a convolutional neural network, CNN, or deep learning. In the deep learning, it is unsupervised process. They are learning from failures. So every time you fail or get an experience, you will learn that this is a failure part. You have to use another part. Same way we have to do in marketing also. There may be 10 factors which are quantifiable, but 11th factor, which is behavior of customer. Now, behavior of customer is driven by many things, and that may be localized, that may be a tradition, that may be some media which is influencing it. So that can't be predicted. So it is like we say, it is as a noise in our data analysis. So it has to have that certain outliers, and we have to judge about its predictability. So in this case, some experts can give the ideas in that area, how much is what is the behavior of that customer. Similar ways we need to get the data surveying only. That is possible.
Yes. Thank you, Professor Nalawade. Very interesting, excellent listening you. And I'm sure that all our participants, many of our students, will get a lot of benefits and will be interacting with you. Thank you, sir. Right. Over to you, Preeti, please.
Sir,
it's one minute.
Yes,
I would like to invite all the faculty members and any participant who is interested in visiting our lab or Mpkv Rahuri. You are always welcome, and we will be very happy to host you here. Even it is not possible for you to come here, we can collaborate in any projects if you are. So we believe in partnerships and collaboration. So we are always open for that.
Sir, in that respect, I would like to say something. We will surely, definitely want your collaboration, because we are also figuring out these robotics and IoT devices in our project. And for that, we need expertise, because these IoT devices are not concerned for one.
Oh, I think so we lost Dr. Preeti.
Preeti, I think some connectivity problem is there from your side.
Yeah, now it is.
Sir, in that case.
Now it is okay. You are connected.
Sir, I am Rucha from the same of this particular kind of project. So recently we have been awarded project.
It will be better if your connectivity is less. Please close your video and you will be audible. Yeah.
So recently, sir, we have awarded one project under Ndvi, which is related to implementation of precision farming, and in that. As per discussion with our Honorable Vice Chancellor, sir, also he has mentioned that we can have a good collaboration with Rahuri, and even Parbani is also having the same kind of project related to smart farming. So, sir, we would be very much happy if we can have some good collaboration with you regarding drone applications, because we are going to purchase some so many instruments which are related to precision farm, remote sensing based, and even we are looking forward to have some expertise on drone applications.
Yeah, it is possible. We are always there, and we'll be ready for any collaboration. No issues.
Yes, sir. Thank you, sir.
Yes, am I audible to all of you?
Yeah, you are.
Kunji sir, Rocha ma'am, am I audible now, right now?
Yeah, Preeti, you're audible.
Okay. So yes, sir, thank you so much. I will discuss my own inquiry regarding those IoT devices, and I will definitely happy to collaborate with you for my own inquiry. So, sir, thank you for now, and we are reaching at the end of this inaugural session. So, Pundir sir, can we go ahead for vote of thanks, or you need to say something? Sir, are you listening? So, dear participants, we reach at the end of this inaugural session, and so it will concluded by the vote of thanks. And on behalf of the entire team, I would like to extend my thanks to our Honorable Vice Chancellor and our Directorate of Research, Dean PG Studies.
Dr. Prabhat Kumar others, though they were saying.
Participants, sir, Prabhat Kumar sir has joined. Yeah. Hello. Sir, Prabhat Kumar sir has joined.
Yes, I'm there.
May I invite him?
Yeah, I'm there, Preeti.
Yes. Sir, would you like to say something to Prabhat sir before proposing the vote of thanks and closing this inaugural session?
Dr. Preeti?
Sir, I might have facing the internet issue.
Dr. Preeti?
Yes, sir.
Yes, sir,
I'm listening to you.
Yeah. Okay. So go ahead.
Hello, am I audible, sir?
Yes, madam.
Yes, sir, am I audible?
Yes.
Yes. So we will start our technical session. Before that, let me thanks to each and everybody who has contributed directly or indirectly in this inaugural session and in this 5 days training program. So my first thanks goes to Honorable Vice Chancellor, our Directorate of Research and Dean PG Studies for his visionary directions and his support as and when we need. Also, I express my appreciation to Chief Guest Dr. S.N. Nalavadi sir for his keynote address in the inaugural session. And sir, it was really pleasure to listening you, and will surely look forward your association in the future, sir. And my wholehearted thanks goes to Dr. Aris Pundi, Dr. Dhabal Kathiria, Dr. N.I. Shah for gracing us with their knowledge, experiences, and continuous backing us to come up with such programs. Thank you so much, sir.
Dr. Preeti,
Yes,
sir,
sir.
Jhala sir
Yes,
is
sir.
there.
Yes, sir.
I think Jhala sir is there. We may request him
Jhala
for
sir?
just 1 or 2 minutes.
Sir,
Yes, sir.
very thank you.
Good morning, sir. Yes,
I
sir.
might
Jhala
facing
sir,
some
yes,
internet
sir.
issue. Maybe because of that, I am unable to see that you have joined this room.
Yes,
Thank you very much.
No issue, Preeti. I will just brief for a couple of minutes. First of all, my apologies because of some other pressing engagements. I could not make it at the right time. But I'm sorry, especially Dr. Nalwade sir. Finally, I wanted to join this for even a brief period if it is possible. I have to rush again now, but I thought that let me join for a couple of minutes and be with you for some time. So I really am very happy that this kind of training program is being organized under a very prestigious project of Anand Agriculture University, sir, and Dr. Pundir and his team is working very hard. Of course, from the different aspects of the project, but one component of human resource development, which is very important. And the topic for this training program, what he has chosen is very important topics in this era. And with your expertise, I just listened last few interaction and your remarks which you are making. And I'm so happy that you have developed this kind of expertise at your institution, which will really have, and I'm really thankful to you, sir, for lending your support and your readiness to work in collaboration with AAU, sir. As a director of research, I'm very happy to know that, and we always look forward for such a collaborative effort. So no doubt we will be in touch with you. Our team will be in touch with you, and let us see, because these areas which are going to be addressed in this training program, which are of course very new to almost at all the SAUs. We have started working on a few of the aspects, and we also have some of the team members or some of the scientists which have started developing expertise in this area. So with your kind cooperation, sir, we will definitely be able to go ahead in a right direction. So I wish all the best for this training program to all the participants. And I also thank all the speakers who have given their precious time to address our participants. So finally, my best wishes for the successful organization of this training program. And once again, my apologies for not being able to join in time for this. Thank you very much.
Thank you, sir.
Thank you. Thank you, sir. Thank you so much for coming in this inaugural session, taking time, making time to say something regarding this training program. Thank you so much. And sir, can we proceed, Munir sir? Can we proceed for the
Yes.
Okay, sir. Yes, sir.
Sir, may I take leave now? Thank you, Dr. Jala sir, and for this collaboration. I will be always there, and our team is happy to share all the knowledge and what we have facilities. Because of NAHP only we can develop such kind of facilities. Almost 22 years I am working in this field, but whatever that NAHP has given in this particular 3-4 years, that is not possible last 15 years. Okay, sir, and so we again I invite all of your faculty and yourself to Mpkv for a visit. We'll be delighted to host you.
Thank you.
Thank you, sir. Thank you so much. So, dear participants, we will move for our first technical session. There is some change in this technical session. So, we were having the lecture of Dr. S.D. Gorantivar on IoT-based smart monitoring system. So, instead of his lecture, because he is busy with some schedule, we will take first the second day lecture, which is on 1st March, taken by Dr. Prabhat Kumar. So please let me give me some time to introduce Prabhat sir. So sir is currently Associate Professor in the Department of Computer Science and Engineering, NIT Patna. He has extensive research experience over wireless sensor network, Internet of Things, data analytics, information security, software engineering, and e-governance. With more than 20 years of work experience, sir has been member of many professional bodies like Institute of Electrical and Electronics Engineering, IEEE, Association of Computing Machinery, Computer Society of India, and International Association of Engineers. He has published various research papers in international and national journal, as well as presented these papers to conferences nationally and globally also. Apart from this, sir is also faculty in charge in Center of Excellence on Smart Agriculture in NIT Patna, where he focuses on electronic and IT equipments in the agriculture. So without any further delay, I request Dr. Prabhat sir to share his knowledge and experience with us for, on application of sensor in smart farming. So over to you, sir.
Thank you, Preeti, for the invitation, and thanks all from Anand Agriculture University for inviting me. Good morning, all participants. So without wasting time, I would like to start my presentation. Is my slide visible?
Yes, sir.
So the topic of this online training program is very interesting and a very relevant topic in today's world, smart farming. And when you say smart, AI, robotics, IoT, cloud, internet, has to be integrated. Smart farming is to increase the production, make the farmers more happy. And this smart farming has given us a very good opportunity. I would say that many disciplines of engineering, agriculture have to come and collaborate together so that we achieve our goals for the future. And that's what is happening today. And we in India are a bit behind in catching up what countries like Israel and Europe, they're doing it in a much better way than what we do. But thankfully, we all have realized and the government has this smart farming. And that's where, we from computer science domain are trying to do our own bit, trying to help the farmers and the agriculture community in whatever way we can do. So my talk basically will start from sensors, and then we will slowly move to IoT, and then how we all are able to help the agriculture community, the farmers together. So that's what is the. So let's first start with the Indian agriculture scenario, because we must know that when we talk about agriculture, the global scenario is a bit different than the Indian scenario. And we have to look at problems and our scenario so that we can come up with technologies and solutions for our farmers. So India is a peculiar and a bit different than what other countries are in terms of our population, the geographical reach, the climate we have. So we will be starting with the Indian agriculture scenario. Then the technology part, to start with sensors, move to IoT, and then we will see how IoT is applied in the Indian agriculture sector and what we are doing at NIT Patna, some research at the end. So let's start with the scenario, Indian agriculture sector. We all know that India is an agriculture-driven economy, and it contributes around 20% of the GDP in 2020. But if you see in terms of employment, it's around 42.6% in 2018-19. So though contributing 20% of the GDP, the employment potential is very high. But this data also shows that the earning of the farmers are less, around 42-43% of the farmers are only contributing 20% to the GDP. So that means there is a lot of scope for us to improve this board data. But India is the largest producer of spices, pulses, milk, tea, cashew, jute, and maize. Second largest producer of wheat, rice, fruit, vegetables, sugarcane, cotton, oilseeds. But if we see our geographical spread, population we have, and the kind of be bigger in terms of the total size, but the total cultivatable land available to China is much less than what we have in India. So in that terms, this data, looks good at one glance, but we should be the largest producer in most of the products as per the availability of land and our requirement as per our population. But that is not there. So that's where the focus is on smart farming, and all of us are coming together to do our bit so that we can increase the production. So we have the largest livestock population, 31% of the global, third largest global fisheries output, 45 of the 60 soil types are present. So that's due to our geographic location on the planet of Earth. we have various types of soil within the same country. 45 out of 60 is too much diversity. So we have 20 agri-climatic region, because one side it is Himalaya and another side it is sea. So, that makes our location very challenging. The 10th largest arable land, it is 6.2% farmers are small and marginal. So that is where, IoT and computer science need to look into. Like, our farmers are small pieces of land. Even if there is a, even in my village, whatever land I have, it's not at one place, it's scattered, small pieces of land and different places. At some of our, farmland, it's very difficult to take machines, because, the roots are not there. So you have to pass through the other farmer's land. So there's so many typical issues. So this is 86.2%. It's a quite large number. So the future of sustainable agriculture growth, food security, and livelihoods in India depends on the performance of small and marginal farmers, because the percentage is quite high. Allocate large proportion of land to high value crops like fruits and vegetables, and also to rice and wheat than other farmers. Thus, they contribute to food security and diversification. So their role is very important. One important point which we must know, that agriculture is a state subject, because the government rules, government policies also play a big role. So specifically put, it's a state subject. So the state government's role is also important. I come from Bihar, and NIT Patna. Patna is the capital of Bihar. So being situated in Bihar, I thought it would be nice to let all the faculty members, research community, scholars to know something about Bihar. The total geographical area is 93.6 lakh hectares. The very typical that river Ganga, one of the most holy river, that divides Bihar into different parts. The upper part closer to the Nepal, and the bottom part is towards Jharkhand. And due to this, there is a huge difference between what is required in the north part and what is these are not equal, but I think we can see in the map. And Bihar is known for some of the worst floods in India. So you can see that geographically, the rivers originate from Nepal and Himalayas, and during rains, the capacity of these rivers are not that to handle the load of water as well as the stones coming from those, and that's why it flood the neighboring region. So that's a a big danger to the life, and but Bihar had learned to live with it, and people now know how to handle it. But that is again a good thing also comes with that. That is one that the flood that brings every let's say alternate year or year, they make the region very fertile. So North Bihar is one of the most fertile region for crop cultivation. But still, if you see the use of technology, IoT in Bihar, it is very less. And that is why the government of India has Center of Excellence in this region, where NIT Patna is also a part, to help the farmers get this knowledge, the technical knowledge. They must know what is required for their field. So the state government is also doing its part. So let us see. Agriculture of Bihar is rich and diverse, endowed with fertile alluvial soil, ground water resources, and the major cereal crops includes rice, wheat, and maize. Pulses are cultivated like arhar, urad, moong, gram, peas, lentils, and kesharia. Largest producer of vegetables dominated by potato, onion, eggplant, and cauliflower. Largest producer of lychee, third largest producer of pineapple, and producer of mango, banana. And most of this data is coming from North Bihar and some region around the capital, that is border to river Ganga. But once you reach towards Jharkhand, the water availability decreases. And so the land quality also becomes different. So major cash crops are sugarcane and jute. So you might be seeing that our Chief Minister is trying very hard to increase the ethanol production for the benefit of the farmers of Bihar, because we have that cane production is very good in Bihar. So how the state government is presently working? We had a collaboration with a nearby district. My just went there and how the state government is working. So the farmer, there is an agriculture coordinator at Panchayat level, deputed by the state government, who is in touch with the farmers at the village and Panchayat level. And these coordinators collect data and submit it to Block Agriculture Officer, BAO. And the BAO, in terms, all the BAO within a district will submit it to the District Agriculture Officer, DAO. Finally, all the district DAOs submit it to the State Deputy Director. So that is the data collection process being done in Bihar at present. But all these collections are manual. So there is no things now. However, some sort of data mining they are using, but still it's not at the level which is required and what the computer people can make it more, intelligent more. And second, the delivery to the farmers. And by delivery, what I mean that they should get the data in real time, If rain is forecasted tomorrow and if you inform him tomorrow, then it doesn't make much sense. What can a farmer do? You need to give him some time. So those things are there where IT and technology and IoT all can help, that the farmer get data in real time and they get it as per his or her requirement. So telling about a particular village to a farmer on his land, whatever land he has, what has to be done there. So that's the state government is trying to do. Let us see what kind of data is being collected. So people who are working in data analytics can see the data types available with the government of Bihar. Similarly, we have seen that other state governments are also having similar data and it's available. So here, as I told you, we went to a neighboring district, Buxar. Patna, we left because, Patna is majorly urban. So we went to a Buxar district, and as we can see on column 4, that these are the panchayats. And during the under this panchayat, there are villages they have selected in each block. There is Thana number and then latitude is there so that you can keep the location. And the last column, you can see the farm holding. And as I told you, this is a typical Indian scenario, especially in the states of Bihar, Uttar Pradesh, and even in Bengal, where the density of population is very high. Though the land is very fertile, it's also very populous. So in a single village, you will have small plots to so many farmers. So as you can see, the farm holding within a village 95, 168. So now you can imagine what would be the size of a single plot. And even these farm holdings may not be, together. So a same farmer may have land in the same village at 10 different places. So that makes the situation very complex. So this kind of data is at Bihar government level. Snapshots. As you can see, the same district and the same panchayat. Now, as you can see, that they have put some target for soil collection, and they have this is the collected value in the lab. Out of that, they are taking random sample and testing almost 50%. And then soil health card is issued to the farmers. So this one thing which state government is issuing to the farmer after testing their land, their actual. But again, these all things are done manually. So it's not possible to test every month or 5 times a year, but they are testing it, at least doing something. So this is the soil health card. This is the actual sample. I take Buxar. And on the first part, you can see on the left top, there is a recommendation to him. Now, this recommendation has come through the testing result of his land. So this is a typical soil test result coming from an actual farmer. So as you can see, they are testing on these 12 different parameters, the pH value, and there is a test unit. And on the right side, you can see at the normal level, and then the rating for his land. So he has got a value of 7.48, so it's moderately alkaline. The electrical conductivity value is 0.65, and now it should be between 0 to 2, so it's normal. Organic carbon 0.4, below the normal range, so it's generally based on the normal range, you can have medium, high, deficient. So this farmer, for his particular land, he is deficient in sulfur and available iron. So there the deficiency is much more. So according to his report, they are recommending him for sulfur and iron. What that farmer has to do for that part of land. So this is they get a health card number, and the farmer details is Ghanshyam Tiwari ji, and then date of sample collection. So we went just before COVID. So you can see the date is 26/6/2019, and then his plot and all those things. And that the irrigation is coming from canal or you have some other source, and tagging it with a GPS position. And some general helping rules are given at the end, that excess use of fertilizer is injurious to the soil health and plant growth. To use fertilizers judiciously, reclaim, and so these are the, so agriculture people know better than me that there are some guidelines to the normal farmers in India. So I want to just explain one more scenario. So how actually the farmers work. I also come from a farmer's background. So what we do, a farmer, especially in Bihar, he knows that this plot is good for sugarcane. And that was told to him by his father, who heard it from his father. It's coming from grandparent that this land is good for a particular crop A. And now he had learned what soil or what fertilizer also from his grandparents and using the same thing. Now he is not bothered that after every year using the same fertilizer have made that soil rich in that sulfur or whatever, but he is still using the same. He has, in a way, he just copying what his forefather used to do, and he's not bothered to know the latest techniques or whether that soil has now become unsuitable for crop A, and now he will gain more by planting crop B. He is not even tracking this weather changes due to so many the pollution and the temperature. So he is still using the same methodology, the same timeline, the same sort of fertilizer mix which his grandparents used to be, and that is what is happening, and that needs to be changed. And that's where we need to come up with so many solutions. And those solutions, definitely without using technology and IoT, it's not possible to reach to each farmer. And government alone can do its part, but we as a research community have to do our part also. So this is what is the actual scenario. I hope you will get some idea what is happening in Bihar. Here you can see some sample data slides, like we have districts here. Now, from the state level, what is available with the NIC and all here, subsoil, microcrops, so what we could put in one slide. So this is a sample soil data available at state level, all district wide. Now, if you go to district, then they have the data from the panchayat level, from village level. So a lot of work from people who are working in big data, data analytics. So here you can again see the state Bihar, and if we have taken one district name and crop year, so the season and then crop, and crop wise the area and the production. So that data, but again it's all manual. Here you can see in this slide that all the 38 districts of Bihar we have covered in column 1. And then based on banana, guava, the area and the production, they are. And then we try about the accuracy of these data, then things become difficult at the block level, because they are asking the farmers and typo error or what, even the filtration done it mostly done by the people at data entry operators. We are dependent on the data entry operators and the talk coming out from the mouth of a farmer. So the accuracy of data may be increased a lot if we use technology, we use drones, we can have a track. Let's say a farmer saying, I have produced this much. So he might say that in order to, there are so many factors. But if you can track, use image processing, satellite image, drone images, then things will be more. So that's where we should use technology. Here you can see they have, based on the previous data, the state government do have some targets, and they see that how much percentage of that target is met for each crop, like dhan, makka. So it's written in Hindi, but so it's, so based on each crop, we can set some targets, and then they test at the end that how much of that target is achieved. But there is nobody to guide a farmer. Like, let's say, as you can see, India level, 1 year, if the prices of onions become very high, the entire India starts planting onions, and the next year you throw onions on road. So there is no central monitoring and recommending system for farmers, which is the need of the hour. We need to have all our crops so that the prices are in check. Further, we have to see what we can export. Our imports bill are already very high, and one reason is that we are not planning it properly. So the target, and so this is again done in a passive manner, and nobody is there to guide farmer as is required today. So they are doing whatever they can do. Just we are collecting data as of now, but now time has come that we make the farmer available the data specific to him and how his income can be increased. So the major agriculture challenges is increasing food demand. Food production by 50. Low yield. India's farm yield is 30 to 50% lower than developed nations. The reasons: low soil fertility. Again, the reason that we are still using what our forefathers used to do. We're not using technology, not using the best of methods, or the best of crops are not selected for that particular farmland. Pest and diseases, still, if a portion of the field gets infected, the farmer using his whatever knowledge coming from left and right, friends and this, he will go and buy a pesticide and do it for the entire field instead of focusing to a particular area. And then the technology use is still very low. Farm loss challenge: 1/3 of the food is wasted. Now, climate changes, inadequate storage facility, surplus production, all needs to be handled. Definitely, different sorts of people have to handle at different level. And then we have limited natural resources, at least at many places in India. Water is a big problem throughout the world, and so have we. So there's a video slide. I hope you will like it. That is a concern for the future. And Priti, just let me know if the voice is coming in the slide.
Yes, sir.
If you want to feed the world in 2050
Yes, sir.
and the next 40 years.
Just a minute. Sound on.
If you want to feed the world in 2050, then the next 40 years, we need to produce the same amount of food as we did over the last 8,000 years. And that gives a little bit an indication of the pressure on the food system. We just face a huge challenge with a growing population, with the changing consumption behavior, the climate crisis. How do you secure your food production? Real secret is the sustainable production. It should be with less inputs, less fertilizer, less pesticides, less water. It needs to be sustainable. Otherwise, we will destroy our planet.
The security of the food system is one of the world's most pressing challenges. But the story of how this small country became an unexpected food superpower might just have some answers for how we tackle it. Consider this. If everyone on Earth ate the diet of the average American, that would require all the habitable land to be used for agriculture, and we'd still be 38% short. And that's right now. What do we do when there are 2 billion more people? Well, the key is more exciting than it sounds, and that's efficiency. Basically, how do we produce a lot more on the land we're already using and do it using a lot fewer natural resources?
When it comes to sustainable agriculture, one country has seemed to crack the code. Bolstered by a national commitment to produce twice the amount of food with half the resources, the Netherlands has become the world's #2 food exporter.
There was a very close collaboration between the organizations and the industry. And they started out of a common interest. So they say, okay, yeah, we want to go for sustainable production, but everybody was aligned.
Everyone involved in the system was aligned and embraced innovation to reach that shared goal. And that has driven efficiency on a level unmatched anywhere else in the world. If there's one place that approach is most clear, it's in their unrivaled greenhouse growing operations.
There's a very nice example about tomato, which really gives a good insight in how we want to produce our food in a sustainable way. So if you produce tomatoes in an open field situation in Spain, then you will end up at the end of the growing season with 4 kilograms per square meter. If you do this in a high-tech greenhouse in the Netherlands at the moment, you will end up with 80 kilograms per square meter, which is more. But the best part of the story is that 8 grams of tomatoes, we do it with 4 times less water compared to an open field situation. And water is one of the big challenges that we face. I just had a cup of coffee. Do you know how many liters of water were needed to produce that cup of coffee? Rough guess. 150. So high technology offers really a possibility of producing a lot of food per square meter in a sustainable way.
The Dutch lead the world in tomato yield while using a fraction of the water that other countries use. But it's not just tomatoes. Measured by yield per square mile, they're the world leader in the production of chilies and green peppers and cucumbers. Number 5 for potatoes, onions, and carrots. The list goes on. But the bottom line is they've been able to get so much out of little.
If we are able to 80 times more with 4 times less water, that's great. It's great.
So, as we can see and agree that what can be achieved if proper technology is used. I have been to Netherlands and I have seen them doing these things, and I was really shocked. And then the way they take agriculture and the quality of life, especially the quality of health is also very good, because they produce good, they eat good, and they work also, work hard very much, cycles and all those things. So they are very close to nature. Technology they are using in agriculture, and that's why I put a slide. So we in India, we are you people, the young future scientists, you are there to take India to new heights, and we cannot do it without using technology in agriculture. So let us see then what are the important factors, the risks in agriculture as a whole. And I hope we all will agree that in agriculture, the biggest risk is production risk, because it depends on weather, the climate change, and it's changing. It's not fixed, with the kind of pollution we are creating with war and all those things, happening. It will change further. Then the labor, mechanization is there, but we have COVID can force movement of labors from one part to another. And the knowledge part, that's where this our role becomes very high, that how, the agriculture people can come up with the knowledge But making those knowledge reach to the farmer in the real time is the challenge to the maybe computer science and other IT people. Quality inputs, that's where we need sensors, we need real-time data, we need, because if the input data quality is low, what the output will be affected. And then access to credit system, because, they should not, it becomes so sad to hear the suicide of farmers. We in India are still unable to, stop it. So we must come with solution to all these things. Then there are post-harvest risks also. A farmer doing all his hard work and coming up with a product and not getting even the cost of his production, or even due to any environmental factors that is lost in the field itself. So we need to come up with storage. Then the market risks are always there. As I told you, if there is some sort of guidelines for the farmer that state-wise, or how it will come, there should be a system that one product is not cultivated much more than what is required. And then we should, even for prediction, we can consider the global scenario. Let's say we are producing some product which is more than Indian consumption, but if we can but that's not consideration, those data should be made available to, and some sort of a central authority is needed which comes up with those kind of things. So still we are importing so many things and wasting on road so many things. So that's where ultimately we have to accept that our systems are not robust, and needs to be improved. So high level of information asymmetry due to variety of regions. Access to market is still a challenge due to high transportation cost, price volatility, rapid degradation of land and soil. For that you need to check it or have some sensors which can send data as and when some major changes do happen. Then there are ecological risk like limited land and limited the kind of urbanization happening. So we need to come up. The Indian agriculture sector needs a proper planning, and we at various stakeholders, I can say, needs to work in tandem to come with a easier life for farmers. Now, going to the technology part, I was told that we have variety of the audience is quite diversified, and there are farmers, there are all sorts of people. So let's see some sensors for agriculture. Some background knowledge about sensors, that when we say sensors, it's actually these four components. We have a transceiver system, a radio which can transmit and receive signals, and microcontroller which can process something, and these sensors and which can sense some event, all requires power. Then power, different sensors can have different way of powering this system. Today we have solar power sensors also, and depending on the terrain and the requirement, we can power it through external power source or through battery. But overall, the circuit diagram, you can say the block diagram of sensor is the same. That, and normally sensors are tiny, but in IoT systems we can have bigger sensors also, because so the objective is, again, the sensors are used for monitor activities, gather and fuse information in real time. Maybe with the labs we can do some sort of aggregation also at sensor level if real time data is not required, like weather data. So you might not require every millisecond or every second. So we can have that. Okay, you send a data at 10 a.m. and unless it change again, you do not need to send it again. So those kind of aggregation and fusion can be done at sensor level also. And then finally, whatever you sense, you need to communicate with global data processing unit so that it can be, some algorithms can be applied, some meaningful information can be got from that data, and farmers may be informed on time. So this is what sensors are. Let's see how these are the circuits. As you can see, there's a power, external power connector. So today's sensor have multiple powering option. Normally consist of an antenna, especially in agriculture part. We do not have that very side limitation. In war zone and all, the sensors need to be very small, invisible to eye. But we are concerned more with the agriculture. We have size. There are external RF connectors, radio, and expansion connectors if you need to connect multiple other sensors also, and you can have batteries. So the sensing unit, it's collect data from the environment. It can be physical data like chemical data, biological data. So we have different type of sensors for different part. So we can detect light, sound, magnetic, the gases, the chemicals, the bacteria, viruses. Just imagine if somebody comes with a sensor which can detect COVID virus, he will be a billionaire. You know, I think we all are ready to buy. So then this sensing unit, whatever it sends, needs to be, processed. And for processing, you need a small processor there. So that gives them smart object, smart farming, smart sensing, whatever. So what makes them smart? That's a microcontroller that gives object their intelligence. And they have all this hardware. Some of them are, written here. So mostly for the use of computer science. So, but as you can see, the RAM, we know the RAM size is 10 kb RAM. Just imagine what your mobile has. It's 8 GB, and now just see here 10 kb. So you can imagine the what kind of storage is available locally. But it can be increased when your size increases, but that will have some effect on the cost. So we have some ROM. Communication device, a radio transceiver, the power source, vibration, battery power. Now today we have sensors which can work by your touch only. So the kind of power required is enough. You touch it, and there are so many modes available made by most of the leading companies. So everybody today working on sensors. Now let's see what kind of sensors are available in. We have some categorization, like acoustic sensors are available that can work on wave spectrum, wave velocity. Now you can have biological and chemical sensors, including fluid concentrations. Then there are electric sensors, charge, voltage, current, all sort of things, conductivity. Then the magnetic field are there, the thermal sensors are there, mechanical sensors are there. You can have, so a lot of things are already available. And in agriculture domain, many soil and crop properties can vary within a field itself. So even if you have a small land, it's not one part of that may be more wet than the other part due to the boundary conditions, the watering done by the neighbor farmer and all those things. So one sensors won't be enough in a field, So you can have sensors depending on the situation where you want, what information you are collecting. So there are texture sensors which can, well, the texture can vary, the pH can vary. So organic matter, water, everything can. Similarly, the slope also do matter. If your land is slopy, and what kind of slope, how much water it can retain. So even that can be tracked using sensors. The density and morphology of crops content of water and various minerals, and then infestation of crops by different weights and by various pests, as I think my previous speaker was also telling use of drones and all. So you can have track. Some of the agriculture sensors, mechanical sensors, we do use probes, transformators, soil compaction and mechanical resistances detection, detecting force used by roots in water jobs. Sensors used in agriculture that measure the light, measure soil properties, uses photodiodes and photodetectors. They can easily determine clay, organic matter, and moisture contents of the soil. The airflow sensors are capable of measuring soil air. They can measure the compaction, structure, and soil type. Location sensors, you're using it from along that. As you can see in the soil card of Bihar farmers, they have the GPS, the location. Then there are electrochemical sensors. You can measure ion selective electrodes. Then you can use ion selective field effect transistors detect nitrogen, phosphorus, sodium. These three are very important. And then using electrodes, you can measure electric constant of the soil, sense soil moisture content. So, and many more. And the list is quite high, and which time new sensors are also coming. So if you see the optical sensors, they use light to measure soil property. Soil reflectance and plant color data are just two variables from optical sensors that can be aggregated and processed. Depending on the value, you can come up with different logical conclusions. And they're developed to determine clay, organic matter, and moisture contents of the soil. Then there are electromagnetic soil sensors, as you can see. Use electric circuit to measure the capability for soil particle to conduct or accumulate electrical charge. Electric soil properties are influenced by salinity, organic matter, and moisture content. So based on the value, you can detect some information from there. Other soil properties such as residual nitrates or soil pH can be predicted using these sensors. So then there are mechanical soil sensors used in agriculture field. You can see the figure that cuts through the soil and documents the force measured by pressure scales or load cells. So location sensors we all know. Now, how to choose a sensor for agricultural field? So based on the environmental factors and economic factors and the correct, we can decide what sensors are required for our field. So the environmental factors may be your temperature range, humidity, corrosion, size, overrange protection, and the economic factors can be cost, availability, lifetime, and the sensor characteristics, the sensitivity, the range, stability, and so on. So we need to come up. That's where if we can make our sensors which can be attached to our mobile, then some of the costing part can be reduced, like the microcontroller, the transceiver, even some of the sensors are already there in our mobile. So we need to come up with very low powered sensors which a farmer can afford and the farmers can use. Then we need to come with interfaces in local languages for computer science people, so that a farmer can work on those sensors and all. So how to choose a sensor is definitely depends on availability. And now we are moving to those direction where the sensors are have already become cheap, but it's going to be more cheaper, where you can have many sensor in a field, and that can communicate with maybe your mobile, and then most of the part can be handled by the mobile, the computation part, the transceiver part. So these things, people are working on that. So again, I would like to share a video about how sensors used in. Again, I have taken Netherlands as. So let us see.
Most people know that greenhouses allow a grower to tweak every little thing, but the Netherlands is taking it to the next level. They perfected the greenhouse as the ideal environment to continuously test and implement all kinds of ways to optimize growth. From things as simple as testing what hues of LED lights can increase pest resistance and improve nutritional value, to things as crazy as moth-killing drones.
So we're at the moment, we don't have any products who can control actually the moths, and finally they will produce caterpillars, and those caterpillars can do a lot of harm to many different crops. Well, the drone is able to detect the moth, also to see how it's flying, its wings, propellers. It just will crush actually the moth.
The relentless drive towards innovation, better and more efficient growing techniques. They've even started taking the human touch completely out of it. Some of the latest tech relies on AI to learn plant behavior and constantly adjust conditions without any input from a farmer.
For example, what we're testing in this compartment is a climate computer. So we have different sensors. Plant activity. Based on plant activity, the computer is actually controlling the whole climate by itself.
Ultimately, the key to solving our global food challenge isn't just in relying on super efficient food producers to carry the weight for everyone else. It's learning from and adopting that technology. At the World 40 Center, you see that effort firsthand in an ongoing experiment. They've built basically a greenhouse within a greenhouse. Inside the larger structure, they're able to replicate the climate to figure out what modifications need to be made to realize the same yields they're getting in the Netherlands and any other country on Earth.
We have a whole project going on with Colombia, and we can in fact mimic, we can emulate the current climate conditions in Colombia, put their crop in and see how crop behaves under the circumstances that we have in Colombia. We can totally flip the seasons around. We can make it a sunny day on Christmas. We can close the curtains on a sunny day and make it completely.
So as you can see, people are using sensors for real-time work, and it's not that everything has to be manual. So whatever control you want for a particular crop, the computer controls everything from the sensors. So automation, that's what the whole purpose of this kind of process. So we are moving towards automation, and that's where IoT, the sensors, the network, the AI, the data analytics, all are coming together. So definitely we are catching up with the rest of the world. Now I want to take you to the next level, that is, can one single sensor do anything? So a single sensor can sense a particular area, a small region. But when we talk about a field, an outside area, we require a network of sensors. So that's what called wireless sensor networks. And we can, in technical terms, it may be represented as a mechanical, where N is the set of sensor nodes and R is a wireless link between nodes P and Q. And that comprises of sensor node and base station. Now, base station is what we call the controlling station. So a sensors can be deployed in a field, and this base station, if we put it a separate hardware, it becomes a bit costly. But if we can plan in such a way that maybe our mobile becomes a base station, things will become much easier and less costly. So now we need to move ahead from one sensor to a group of sensors working together, maybe forming in a network, communicating with a base station. Base station can be stationary, can be mobile. And then this base station may have more in terms of battery, in terms of size, in terms of wireless communication. So the sensors can be small, and then this kind of network, ad hoc network, sensor network is required. The deployment, now you can place the sensors going manually and putting it with that's a fixed deployment scenario. You can spray it in a particular area, the random scenario, or you can have some of both. So that depends. So deployment scenario may be random, fixed, or hybrid. The application summary of the wireless sensor network, that you can detect an event and report. That can be intruder detection also. Intruder in agriculture can be, the insects, and all those kind of, in different cases, the intruder may be different. You can detect even fires and other things. You can monitor temperature by data gathering and periodic measurement. And even in industry or the agriculture industry, you can have the manufacturing process monitoring, and you can track the movement of patterns of insects or anything, So using sensors, and if we have a group of sensors, we can really come up with some actual workable solutions which can be deployed. Some of the scenarios, just for the sake of completeness, you can detect forest fire, the pollution monitoring, the water, all that can be done using wireless sensor networks, putting sensors in different plants. Let's say the government wants that what is happening at a village level, not only at a field level. So you can come up with sensing data from lots many fields, and then you can analyze and come up with some quality monitoring part. Military surveillance they do use, but today's context is not there. Even in India, they have deployed it in Kerala, which detected successfully in 2009 landslide detection. So WSNs are deployed. Now, I wanted to come up with this that how this a lot of people get a bit confused when with wireless network and Internet of Things. So let's discuss this. That IoT, the term IoT is and sensor networks are related in to some extent. If you see 2004 data, it's actual data from Google search trends. In 2004, people used to search for wireless sensor network nodes. At that time, the sensors were becoming popular, and the research community was able to see the sensors actually deployed. And IoT was just beginning to come up, because when we were working with sensor networks, in wireless sensor network, the sensor size had got a limitation that it has to be small and the is very less. But at the same time, people started coming up with sensors which do not have those kind of limitations, a bigger it overlap. So IoT and sensor networks both were being searched equally. But see, around 2012-13, suddenly, with the availability of sensors, different type of sensors, more powerful battery, and the reach of internet, or you can say wireless communication technologies, WSN has, reduced its significance as IoT has become the superset. So today, IoT is the word. WSN becomes a part of IoT. Even if we are spraying sensors in a field, the field part is only sensor network. Rest you're controlling from your mobile. That all goes into the Internet of Things part. So WSN is a subset of things as of now. This slide clears the trend. How to define Internet of Things? Right in 1998, Kevin Aston, he predicted that IoT had the potential to change the world just as the internet did. And he concluded maybe even more so. And now we find it happening in our devices, becoming intelligent, doing things by their own. Formally introduced in the International Telecommunication Union in the ITU Internet Report in 2005. 2005 proposal was submitted in ITU, the body which decide the standards. Semantically, Internet of Things means a worldwide network of interconnected objects, addressable based on standard communication protocol. So IoT is not only about communication, it involves much broader aspects like intelligence using data analytics, machine learning, AI, etc. So Internet of Things is not only getting sensor information and communicating, it's much more than that. And these analytics and intelligence can be done even at the node level, some sort of a, as I give you the example that if I put a sensor in my this room for measuring temperature, and I ask it to send it every millisecond, doesn't make sense, because temperature variation in millisecond is not required unless it vary by 1 degree. Doesn't make sense sending the same temperature information again and again. You're unnecessarily putting burden on the data analytics part, the storage part, even the communication overhead. So we can have some sort of meaningful setups as per the requirement, and that can be intelligent. And data analytics and machine learning has made life even more interesting. Here, it's from one of our papers, Architecting User-Centric Internet of Things for Smart Agriculture. Sustainable Computing SCI journal is there. We have published that paper. It's work of one of my PhD scholar. So here is the diagram. I want to show you the complete, how one actual IoT setup can be and how different words, we use Zigbee, we hear these words, IoT gateway, coordinators, TCP/IP, cloud, smartphone can be used to. Let's see how they are actually interacted. So as you can see, WSN, the sensors, it can be a part of a IoT ecosystem. Now these sensors can communicate with a coordinator. As I told you, if we make our mobile as a coordinator, the life of farmers will be easier. That means the cost will decrease. Otherwise, we can have a fixed coordinator depending on. So these sensors need to transmit data or need power to transmit data only up to these coordinators. Because here, the numbers are more and we are not in a position to go and charge them daily or to replace the battery. So we want very less communication, and the range, the lesser the range, the better the life of these sensors. So WSN is limited to a field. Let's say you deploy sensors in your agricultural field. Now this is communicating with a coordinator. Now this coordinator can be expected having a much better battery and communication. So it's only one, and you can move also, because like if you are using mobile, you can go with your home. You don't need data every millisecond. Now this coordinator can be or is connected to the IoT gateway, since it has enough transmission range and power. So, and you can charge it. So this is connected to the IoT gateway. And up to here, you do not need an internet. It can be without internet. And that's where the protocols used are Zigbee and other protocols. And the actuators can be put here in the coordinator to activate some event. If you want that, okay, whenever the, let's say, the dryness of the soil becomes less than a particular threshold, the water should be automatically sprayed. So that can be done by this actuator. The sensors will give the information, the coordinator will keep on track, and when the threshold becomes less than something, this actuator comes in work and it will start the whatever you have the watering system in the field. So for that, you do not need internet. Let us say I don't want to automate it. I want to control it from my home. I may be traveling. I may be in US and want to control my fields in India. Now there, this coordinator needs to be connected to a IoT gateway, and through this IoT gateway, you need to communicate using internet through the cloud. And now from here, you need internet. By making this accessible to cloud, what you are doing, you are allowing a user sitting anywhere as per his or her convenience, control the actuator or the working of the network. So this is a IoT ecosystem which we need to understand and we need to work with. So computer science algorithms and what we are doing at NIT Patna, we are trying to use our smartphones and cloud and to make the life easier for our farmers. That we will be seeing in our next whatever research we are doing, and in my next talk after the lunch. So this is a IoT ecosystem. I hope things are clear. So when we say IoT, I always think the greatest programmer or the scientist or whatever you can say is the God. We are just copying it. We are copying what God has given to us, millions of years earlier. How our system works. We have sense organ. Fine. So what they do, they are only used to collect. They cannot process. So the perception and sensing environment that you need to collect, and that is the 3 C's of IoT architecture. First, you need to collect, and for that you use sensors. And then you communicate as our body do using our nervous system. You touch by your hand, you touch by your feet, you touch wherever in the body. The sensation, unless it reaches the brain, you're not knowing. What happens when somebody is operated? Or when you go to a dentist for some, so they put in some injection. What it actually do? It's not stopping the collection. It is stopping the communication. So your brain is not knowing that you are feeling the pain. So that is there already given to us, and for controlling, we know the blame, which can analyze, which can take some decision, which can control things. So this IoT architecture, the 3C, collect, communicate, and control, is very much required, and that's what we do. So I won't want to disturb your lunch. So Priti, I think I'm reaching 1. So maybe if anybody has any question.
Yes, sir. There are 2 or 3 questions. If you want to stop your lecture from here, we can proceed these things post lunch.
Yes.
So can we take a question from audience, sir?
Sure.
Yes, sir. Sir, first question, how AI helps in developing hybrids?
You know, intelligence is it's a huge term. I mean, in generic sense, if you're making things intelligent, it needs data. That means if you have data, if you're finding some pattern, some hidden information, and if you are doing it using our mind and our, even human has limited remembering capacity. So you cannot analyze volumes of data. So if machine can be trained on that data, so you can use AI at each level in the IoT ecosystem. It's not at one place. So depending on situation, AI is there, and it is helping, you know, many of the things which AI can do, we cannot do it by humans, by human eye, by human perception. If you see the from monitoring of even a metro station and all, a slight glimpse, and the AI is able to recognize the faces. You know, there has been criminal caught after 30 years, 40 years of the crime. The AI is able to predict based on his or her female history, the aging, that what will be the look of that man after 30 years and being caught and all. So even in agriculture, if you train AI to detect, so once you start detecting that my plant has a certain disease, if you use machine, it can detect much earlier than what a human could do, because of you know, high quality cameras, and even today, as our cities, the machines are able to detect almost better than what a doctor can see from his naked eye, because of the better capacity to handle data and to analyze and to remember things. You know, we tend to forget, and we tend to be getting the human factors come in, like, you know, the stress, your mood, and all those things. That a machine is, you know, not dependent on those factors. So AI is there and helping at us every level.
Yes, sir. That removal of that biasness or human tendency, and not taking that much stress to analyze this huge amount of data. So
right.
Yeah,
and
in that case,
you can start after years from the place where you left, and you become a human, he will forget everything in a year or so.
Yes, yes. Sir, next question is, farming is neither a business nor a profession, yet it is still an occupation. It has several reasons. How the SHF, maybe self-help farmer, will take additional investment risk IoT and AI in absence of stable value chain.
I mean, we need to, you know, it's my personal feeling that we need to come up with those things, that farming is not a business. Unless we make farming a business, unless we make it profitable, our farmers will keep on dying. So let us understand that a farmer, okay, he is doing service to the nation, and all those things are good enough. But let us understand that for a family, his kids, his own food, for everything, he's dependent on that. For him, it is an occupation. We may think in a different way, but for a farmer, that is his livelihood. So for him, it should be a business. He should be in a position. Otherwise, people will leave farming and come to cities and do those things. And so I beg to differ from that question itself. I think the farmers need to get more, and they should, and that's why they are not adapting. Their mindset should be changed. They must be we should remove the middlemen, and this must be taught by the government and whatever machinery that you take it as a business. You deploy technology. You see with the same size of field what an American or European earning, you can earn also, and that will only eventually change the lifestyle of the farmers.
Yes, sir. Sir, actually, that person might be asking what is the investment risk in such IoT devices and robotic devices in terms of farming.
Right. He might be asking that. You see, the investment risks are not very high because those sensors are not going to die very soon. They can be reused. Once, if you have a, let's say, a static deployment, he manually go and put it. So he can track where he has put. He can remove whenever required and use it next season. And as I told you, the sensors prices have decreased significantly. And we can many of these coordinator function in our mobile phones, which the prices are anyway decreasing. So this entire setup doesn't cost high. And we can, again, yes, definitely for farmers, we can have some sort of, since the state government has already people up to the village level, the coordinators who are collecting information, we can have a village bank for sensors. It's a very good idea. Whoever has posted a question, it's a very nice question, that if we have some sort of a village bank for these sensors also, they may be, so this is quite possible. And that's what we need to come up with, those kind of solution. Once we get data, the requirement, a concept of census bank can also be put to the government.
Sir, next question is, this is the last question, role of AI in mitigation of challenges of conventional agriculture in future sustainability.
Yes, it is required. As I showed you, the government has lots of data, but what are we doing with that data? We are just tracking. We are not in a position to, let's say, when the data I showed you was from Buxar, we are not in a position to tell a farmer, here you do these things for your field A, you do this thing for your field B. And again, there are issues of, once the crop reaches to his home or his warehouse, where to sell, how to contact the buyer. He is more to the middleman. We as a consumer are paying high, the farmers are not getting it. Who is earning? The middleman. So technology should come there, and AI should help a farmer at every level. It's not only production. It's about the warehousing. It's about selling it to a right person. So that's where AI is required, and we are using it. Hopefully, things will improve in India.
Yes. So,
sir, I have a question.
Yes.
Preeti, I have one question.
Yes, ma'am, please.
Sir, if we have already developed or we have already installed some wireless network system in a field which collects soil moisture at suppose every 15 minutes or 1 hour. So how can we convert or how can we utilize that particular wireless network for IoT, or how we can convert in IoT? Is it possible or not?
Yeah, it is possible, ma'am. Just I will take you to that diagram again.
Sir, Dr. Rucha Dave, ma'am is working with us in this NAHIB team. He is co-PI of this NAHIB team, and his expertise is in remote sensing.
Yes.
So, Rucha ma'am.
Richa ma'am question is also related to her field only.
Yes.
So, yes, because we have already installed cosmic ray soil moisture sensor and hydrogo soil moisture sensor in 2 different locations, but now we want to utilize it as IoT also.
Yes, ma'am. So there must be a coordinator or controller somewhere, na? From you are getting, let's say.
We have already SIM card in that, and we are getting the data in 3 email IDs at every 15 minutes in one sense from one sensor, and from another sensor at every 1 hour we are getting.
You are getting the data. Now yes. There may be thousands of mail having those 15 minutes or 1 hour data, isn't it?
Yes.
Now the first thing is we need to have those data at a single repository.
Yes.
The first need is that. Otherwise, 1 hour data will not give you any meaningful information.
Yes, yes, sir.
And we need, and there is the importance of historical data as well, as because things are changing. You know, whatever happening this year will not happen that may not happen the same next year.
That's 5 years, sir. Yeah.
And you need to collaborate this with the rainfall data of other departments. You know,
One sense is giving all rainfall data, soil temperature data, and soil moisture data.
so that is giving the data of the field. Now what I'm taking, we need to come up with the data from other government agency about the weather prediction, what is happening to go tomorrow and today, and find a correlation between that data and how it is affecting your field data.
Yes, sir.
So that is where, you know, data analytics come into picture. So first, ma'am, I will strongly suggest you bring all your data to one place in one format.
Okay.
And then let the analytics people work on that data, that how a variation on that is affecting your output.
Okay. Okay.
And if you want to control that, let's say right now you are an automated system for you're only getting data. But tomorrow, if robots are used, if drones are used, when should a drone visit? All that can be automated and that can be controlled using your smartphone or wherever you are. And you will get an actual recommendation. So that part is missing, but the start is very good. And that's where we have to start.
Yes.
So maybe a little more collaboration with computer science people will help.
Sir, I'm actually expecting your collaboration in the future. So I will contact you after the session also. So, sir, should we just end this session right now?
Yes, ma'am. I think give them time to eat at least.
Yeah. So, dear participants, we are reaching at the end of this technical session, and we will be back at 2 p.m. With same Dr. Prabhat sir in the same topic, sensor and IoT in smart farming. So, thank you for now.
Thank you, ma'am.
Thank you, sir.